Good to go?
Yeah, we can.
Okay, so awesome, perfect, thank you. So this is going to be a UX focused talk, but I'm a front-end developer, so it's going to be more from a front-end developer perspective, so to speak. So I'm a front-end dev for DeFi Saver currently, but I also handle a large chunk of the UI design and some UX work. I worked on DeFi Explorer, on Ethereum Trustless, now currently Diversify, and a lot of other dApps on the Center team. So, I mean, if any of you are developers, I think you basically know this, if you've built the dApp ever. So you're going to do everything right. You're going to read all the documentation and you're going to set everything, and it's eventually going to end up working. And even if it seems to be working, it's going to be broken for someone somewhere inexplicably. So, I mean, basically the only thing you can do in the current state of the ecosystem is just assume that everything is going to break at some point. So just to sort of use the trust by verify principle that we sort of have in the community, rely on the whole stack under your dApp, but have safeguards in place. So that's going to be the main theme. But basically, I wanted to share some tips and tricks that we sort of learned over time while building various dApps in the Center. It's just going to be like a large list of basically tips and tricks regarding different parts of dApps. I'll try to keep it as generalized and generally applicable and as possible, and sort of try not to state the obvious that you may already know. So starting from the actual process of authenticating users, a lot of dApps support like a lot of wallets nowadays. Mainly, I think like a large chunk of the users use browser wallets. But even like between them, even though they're somewhat standardized, the behavior is usually very inconsistent. So the injected Web3 objects are, you just can't rely on them. Sometimes they're injected with a version 0.2 like MetaMask does. Sometimes it's 1.0 like I think Status does it. So the best thing you can do is sort of not rely on them, to rely on them as little as possible. Maybe just rely on the injected provider, because you have to use that in order to sign the transactions. So what we've learned from experience, sort of instantiate your own Web3.js or Ethers object and just rely on the window.web3.current provider, and maybe window Ethereum if available, obviously. And also try not to overwrite the injected object. I've seen a lot of people sort of set up their own Web3 object and just sort of set it as window.web3. This just creates race conditions for the Web3 setup, and also overwrites your initial injected provider, so you can't really switch between. So if you support, for example, MetaMask and Ledger wallets, you can't really switch between them because you already overwrote the injected provider. EIP 1102 behavior is also very inconsistent. I'm talking about the sort of authorization pop-up that you get when sort of opening a dApp. So, for example, some wallets don't even have the pop-up. Some just store your authorization permanently. Some require authorization every time. So, if you don't want the user to have the pop-up as soon as the dApp opens, which I've seen a lot of dApps do, it's really hard to sort of already authorized, but there's really no consistent way to do it. So you can really just test around, and you can't really rely on the behavior being consistent whatsoever. Also keep in mind that when using browser wallets, you're using their provided node most of the time. So those nodes can actually fail and also have inconsistent behavior. We've seen some wallets just timing out for a lot of requests, and it's really not, there's not really anything you can do about it. Just be sort of mindful that even that can happen as well. Also keep in mind that wallet accounts can change. So MetaMask can change accounts. The user can also change networks. And you can also, if your dApp allows it, your user can also switch between different wallets. So just be mindful of all the changes that are that can happen. So there's a lot of edge cases to cover. Hardware wallets have a ton of specific stuff as well. I'll just walk through them. For example, Zerion, I really like what they've done with the. So because hardware wallets are sort of a pain to connect, you have to be on your desktop, you have to have the USB and everything, and it just takes a while. So what Zerion did, they just allowed people to have a read-only address that they can input, so they can just monitor their positions without having to connect the wallet. And so try to provide as much read-only data as possible without sort of requesting any action from the user. This goes for browser wallets as well. So if you can sort of automatically show the previous account without requesting authorization, etc., try to do that. So hardware wallets, I've seen some dApps only sort of automatically pick the first account for their ledger devices or Trezor devices. Let the user pick, because hardware wallets can generate a huge amount of different addresses, and users sort of switch between them and use different ones for different things. So let the user know, allow the user to pick sort of the different addresses, and try not to rely on the actual address hash. At least show the user's balance, because they may not remember the address, but they'll see that they have a few ETH on this account instead of the first one. Or also reverse ENS is a nice touch here. So yeah, ledger specific stuff, derivation. It's Ledger has like a legacy derivation and Ledger Live derivation, and then you have some custom paths that you can use as well. So just a lot of edge cases to cover that there as well. So just try not to rely on the default, whatever that may be, and sort of look into the different implementations that are available. Also, keep in mind, hardware wallets don't really have a screen that shows pending notification, pending transactions, etc. So they have no idea if they've already sent a transaction or if it's pending or if it's mined. So just keep them informed. This goes especially when they reload the page. So some dApps have like a ongoing pending transaction notification, but if you reload the page, it's gone. So what can happen? The user can send a transaction to do an action, and then sort of reload the page and have the transaction. Well, the state won't be changed because the transaction isn't mined yet. So what they do, they send the same transaction again. So they've now done the action 2 times instead of once, or 3 times even. We've seen cases like that, where the user didn't know that their transaction was actually still pending. So they did it. So maybe they generated more DAI from their CDPs. They generated it 3 times instead of once. Right, so the actual sending transactions, the actual process. Here we have a few tips that we sort of gathered through time as well. So for example, because everything is obviously permanent, this is especially important for DeFi products, which are super popular lately. So let the user know exactly what they're going to do. So if you know the state of your application after the user's action, let the user explicitly know what they're doing. So here's a screenshot from DeFi Saver that actually shows the after values based on the user's current input. Keep in mind, this is a developer tip. Gas limit estimates will fail. So this is actually specific to transactions that have a variable execution on the contract side. So for example, if you have a on-chain exchange, you might sort of estimate the gas limit to be 1 million and then send the transaction, and then for the few blocks that it takes to mine, the actual order book on the exchange will change, and it will actually need 1.5 million gas or something, and this will cause your transaction to fail. I mean, if you've seen, if you have a dApp and you see cases where transactions are going out of gas, you know what I'm talking about, and just feel free to sort of increase the limit increase the gas limit by 20% or 30% or whatever works for you for those specific actions that the users are taking. Be inclusive when you are be inclusive with different wallets. So keep like some wallet specifics in mind. Again, this is mostly based on hardware wallets. So for example, let the hardware wallet users pick their gas price. We've seen some dApps that just hard-coded to 5 GUI or 10 GUI. Yesterday, we had an emergency situation with the network congestion. The gas price was actually, the safe low was 120 at a certain point, which is unprecedented. And just let the user be able to react to those network changes and sort of let their, if it's an emergency transaction, let them sort of send it with a higher price. And definitely take into account the current network conditions. So we mostly rely on ETH gas station, but you may want to rely on something else because I think they're deprecating their API, but sort of let the user pick what they're going to send. Because again, hardware wallets don't have as much support as for those features as, for example, MetaMask users or different browser wallet users or mobile users. Also, take into account the gas fee for the transaction you're sending. So especially if your transaction is sending ETH, make sure to decrease the max value for the ETH amount to take into account the actual transaction fee. Also, if you're, so for example, if your user is exchanging ETH for DAI or whatever, you may want to assume that they want to afterwards send the exchange DAI to a different address or use it for something else. So take into account the next transaction as well. So at least warn the user that they will have 0 ETH after this transaction. Diversify does this, for example. When you wrap your tokens, they actually decrease the max amount for your ETH for 0.001 in order for you to be able to unlock your ETH after trading. Speeding up and canceling transactions. This is a feature that I think only MetaMask currently supports, but it's a very useful feature. So they actually allow you to speed up your transaction or resend it with a higher gas cost. And you can also cancel your existing transaction. So this is very hard to provide as an option from a dApp standpoint. For hardware wallets, you would have to track the nonce, and you would have to probably monitor the mempool. And for browser-based wallets, you won't be able to specify the nonce. So I don't think you'll actually be able to provide the option at all. But at least if you want to track the transactions that are being sped up or canceled by the user. So for example, if they do it from MetaMask, this is actually also hard to do because you would need a third-party solution that actually monitors the mempool. In DeFi Saver, we use block native. So for example, if the user sends a transaction and they actually cancel it, we monitor their transaction through block native and then sort of provide the notification that the transaction has been canceled or sped up. And also, again, be aware that this shouldn't be based on the current application states or your Redux or whatever, because the user may reload the page or they may open it from a different device. So you may want to keep the history available in that scenario as well. At least in order to sort of prevent this previously mentioned scenario where the user isn't aware that they have a pending transaction as well. Right, fetching and updating the data. This is something we've had some issues with on DeFi Saver, especially because the most common scenario dApps do is basically lazy loading. So when the dApp loads, you sort of fetch the data initially, and then only update it if a user has done an action that updates the state for whatever reason. So some issues with this are actually like you may not be. So what you actually do is wait for the transaction receipt, and then after the transaction is mined, you refetch the data. So the first issue is obviously sometimes the transaction doesn't get mined within 50 blocks. So Web3.js won't give you the receipt after that. So you have to figure out this whole special process to sort of fetch the receipt after the 50 blocks to sort of pull it somehow. The transaction might be canceled as well, so you can't really, or sped up, which gives it a different hash, and that's a special set of problems. And even if the transaction is mined and you sort of refetch the data again, what sometimes happens, even if you get the response from the RPC node, the transaction is actually already mined, and you refetch the data, you will receive the old data. So, for example, if you create a trade, and then you get the trade ID from the receipt, and then you fetch the data from the contract for the ID that you got, the node will actually maybe tell you that it's not available or it doesn't exist. So what you can do, if you know your data exists, one way to handle this is sort of implementing a fetch with retry. So basically, if you're certain that you've created some data, you can sort of fetch, like maybe a loop your fetch function. So try to fetch the data, and if it fails, sleep for half a second and try it again. And then if it fails, try it again 10 more times. This actually works most of the time if you're certain that you will get the data in return. And if in cases you can actually be certain that you've received the data. But if it's a data update, then it's really hard to do universally. And another thing you can actually do is mock update your state. So for example, if you actually know precisely what's going to happen, so if you know that a certain value will be changed to a certain different value, if you know the exact data, you can actually just mock a state update instead of fetching it from the chain. Some other approaches obviously include polling the data from the chain constantly, like maybe every minute or 5 minutes or 30 seconds or whatever. This really adds up easily because people leave their apps open, they leave the tabs open, and you already have 1 million of RPC requests coming in and out to your node provider, and that just adds up really, really quickly. Another way to handle this is have a separate API service. This is just a whole special set of complications that's hard to discuss universally, and it's just a whole talk of its own. And this is an approach some dApps use as well, but obviously it makes you more centralized, but it can, if done correctly, provide good UX for your users. Right, some other random bits. ENS resolution for your address is always a nice touch. So for example, if you have a address input anywhere, make sure the user can actually input their ENS address. And if you have a user address or any address, really just try to reverse resolve it via ENS. It's always a nice touch to see that. Also when showing numbers, hashes, or addresses, a lot of the apps just show for example, for the hash, they show the first 4 and the last 4 characters, which is absolutely fine. We never sort of show nor remember the full hash or the full address. Same goes for numbers. We just aggregate the number or format it. But a lot of the apps actually don't show the full value. Instead, they just show the formatted data. So showing the formatted data is fine, but let the user know their precise data and their precise amounts, their values, their hashes. Allow them to at least copy the precise data or have it in a tooltip, because there's really no other way for them to get the precise data. I think that's all the tips I sort of prepared, and that's just the 19-minute mark. So these are just the tips I had sort of listed really quickly in a presentation. If you have any better approaches for the problems I mentioned, I'd love to hear them, and please share them. And please let me know if you have any questions. And I think that's all from me today.
Thank you so much, Nikola. I have a question actually. Which do you think currently is addressing almost all the things that you mentioned, and who is doing it properly? You mentioned Serion.
Right, right. Well, I personally work on DeFi Saver, and these are mostly the things that sort of we found to be user frustrations, or the ways we found to improve user UX. So these are mostly the things we implemented, and I'm trying not to say that this is the correct way or these are all the UX tips that you can give. But we've mostly implemented these, and we've sort of stolen a lot of stuff from Ethereum, from Diversify, which I've included some screenshots from. I don't personally use as many dApps as I'd like to. I've noticed 1inch has a very nice UX around the actual, a lot of exchanges exist, but for example, 1inch, and I think I used Kyber as well. They really sort of try to handle all the edge cases and sort of the price updates and the gas fees, and they sort of really took a simple process and ironed out all the possible inconveniences that I didn't personally even know I had. Those are the few that come to mind. Zerion is very nice for their UI, and they've done some really nice features as well. If anybody in the call has some dApps to share as well, I'd love to hear them, and I always love to see some nice UX work.